Hi students, welcome back to the class. Today I am going to explain the topic evolution or absorption of heat. It is one of the important characteristic features of the chemical reaction. What is the topic? Evolution or absorption of heat. Okay, so according to this reaction, sometimes the heat is evolved or sometimes heat is absorbed, and both reaction is conducting in the same time. So I will give you information and a detailed explanation about this topic or about these characters. First one, the reactants. I hope all of you know what is meant by reactants. The reactants react to form a product, plus produce the heat energy, otherwise some other energy also produced. So in this topic you will get the information about the reactions after getting the light energy or the heat energy, otherwise both light and heat energy. Let's start the first one. Evolution or absorption of heat. The first one, evolution of light. So some of the chemical reaction, after the reaction, that reaction produce the light energy. So here magnesium react with oxygen into form a magnesium oxide. Magnesium oxide MgO. So here this reaction magnesium means magnesium ribbon react with atmospheric oxygen that produce the brilliant light, otherwise the dazzling white light is produced. So this reaction is the best example of the evolution of light energy. By the production of the product magnesium oxide, we easy to identify the color and easy to identify the light energies produced in this chemical reaction. That's the first one, evolution of light. So here which energy is formed? Light energy. So the reactant names, one is the magnesium and second one the oxygen, react together into form a magnesium oxide with the dazzling light flame. So this example is a production means evolution of light energy. And next one, evolution of heat. Some of the chemical reaction, after the reaction is produced the heat energy also. Heat. So I will give you the one example about the how to heat energy formed and which reactants needed for the chemical reaction. So here evolution of heat, magnesium and the hydrochloric acid We want to take the small piece of ribbon, means magnesium ribbon, and put into the test tube and add hydrochloric acid into the magnesium. What happened? The product magnesium chloride is also formed, plus hydrogen gas is also formed, and we will see and identify the test tube slowly warm. Heat, heat is produced. The reaction between the hydrochloric acid and magnesium, there are 2-3 products is also formed. The first product magnesium chloride, second product hydrogen, the third is a heat energy. Easy to identify, that means that we will feel the heat, means that test tube gradually increase the temperature, means the heat, produce the heat. Okay, so it is the best example for the evolution of heat energy. So what is the reactants in this reaction? Magnesium and hydrochloric acid. What is the product? Product magnesium chloride and the hydrogen and the heat energy. Okay, and come to the third topic, evolution of heat and light. Some of the chemical reaction that product, maybe the light energy is also formed and light energy also, light and heat energy produced in the same reaction. So but best examples given here, charcoal, coal react with atmospheric oxygen into form 3 different products. The first one is carbon dioxide gas is also emitted out, and second one heat energy and light energy also formed. The coal react with the oxygen into form the carbon dioxide. Carbon dioxide is a gaseous form, is emitted out, and the light energy and the heat energy also formed. This is an example of the evolution of light and heat energy. So I repeat once again, the characteristic features of chemical reaction. The third one, evolution or absorption of heat. Based on the heat evolution is classified into three categories or three best examples given here. The first one, magnesium react with the oxygen into form magnesium oxide and light energy is formed. And second one, evolution of heat. So here magnesium and the hydrochloric acid react into form magnesium chloride, hydrogen and heat energy. And third one is also evolution of both heat and light energy. And next topic, exothermic and endothermic chemical reaction. Exothermic and endothermic chemical reaction. So here, based on the heat energy is absorbed or evolved, the chemical reaction is classified into two categories. First one, exothermic reaction and the endothermic reaction. What is mean by exothermic reaction? The exothermic reaction means the heat energy is evolved. Heat energy is evolved means produced in this chemical reaction is called exothermic reaction. What is mean by exothermic? Exothermic means heat energy is evolved. So in this chemical reaction, the heat energy is produced. This type of energy, this type of reaction is called exothermic reaction. And next one, endothermic reaction, just opposite. Means while the chemical reaction that reactants need the more energy, they are absorbing the energy. Absorption of energy is called exothermic reaction. I will explain that one. How to the energy produced during the exothermic reaction, how to absorb, what is the reason for absorption, what is the result of absorbing the heat energy, I will explain to you. Listen carefully. The first one, based on the heat, the chemical reaction classified into two. The first one, exothermic chemical reaction, means exothermic reaction. So here, calcium oxide, CaO. That means calcium oxide, simply quicklime. So this calcium oxide react with water into form loads of heat energy along with the calcium hydroxide also formed. What is the product? Mainly heat energy and calcium hydroxide. While adding the water over the calcium oxide, what happened? Let's produce the bubbles. As a result, produce the heat energy. So it is the best example of the exothermic reaction. So calcium oxide react with water into form calcium hydroxide plus heat energy. Okay. Second one, endothermic reaction. So here given the two different examples. Endothermic reaction. Endothermic reaction means heat absorption process. Heat absorbing process is called endothermic reaction. Okay. The first one, nitrogen react with the oxygen into form monoatomic into form nitrogen monoxide, NO, two molecule of nitrogen monoxide. So here the nitrogen and the oxygen, they are ready to combine. So for the combination, for the combining, they need the huge energy, heat energy. There are more than 3000 degrees Celsius, 3000 degrees Celsius required for combine the nitrogen and the oxygen into form nitrogen monoxide. For the production of nitrogen monoxide, they need the 3000 degrees Celsius. So that's given here. In this reaction is also energy, means heat is absorbing process. Here the heat is absorbed into form a nitrogen monoxide. And next one, calcium carbonate. Calcium carbonate. So this calcium carbonate want to break into two simpler forms. They need the energy, heat energy. There are 1000 degrees Celsius energy required for the breaking of calcium carbonate. Breaking the calcium carbonate into form calcium oxide plus carbon dioxide. What is the requirement of the heat energy in this reaction? There are 1000 degrees Celsius. So I hope all of you understood this topic. What is mean by exothermic and endothermic. Thank you.